Okay, so let's do a problem example where we have a propeller of a World War II fighter plane that's 2.3 meters in diameter. We want to know what its angular velocity is in radians per second. If it's spinning at 1200 revolutions per minute, then we want to know the linear speed of the tip of the propeller. Then we want to know what the centripetal acceleration is, and we want to know that in meters per second squared, and we want to convert that into multiples of g. So how do we do this problem? The same as any other physics problem, we start by writing down everything we know. So we know that the diameter of this thing, of this propeller, is going to be a diameter that's equal to 2.3 meters. Then we're asked to find the angular velocity in radians per second if it's spinning at 1200 revolutions per minute. So we already have an angular velocity. We have an angular velocity of 1200 revolutions per minute. And in part A, I want to know what this is in radians per second. So I need to do a conversion factor. So I need to convert from revolutions per minute into radians per second. I can do the factor label. This is just basic unit conversion. So first I want to get rid of the revolutions. So I need revolutions in the bottom. And I want to turn revolutions into radians. So I need to know how many radians are in one revolution. A revolution is once around a circle, and we know that there are 2 times pi radians inside of a circle. That's by definition from the chapter reading. And then I want to convert my minutes into seconds. So I get rid of the minutes by putting the minutes up top. So those will cancel out. And 1 minute is equal to 60 seconds. So if I look at this factor label method that I'm following, I can see what units cancel. I can see that a revolution is up top is going to cancel with the revolution, and I'll end up with a radian on the top. And I can see that the minute on the bottom cancels with this minute up top, and I end up with seconds on the bottom. So if I do this multiplication, 1200 times 2 times pi divided by 60, I get a final answer of 126 radians over seconds. And that is the answer that we want to part A. Part B, we're asked to find the linear speed. So I need a conversion factor between angular and linear speeds. It turns out one of the equations that we know is that linear velocity is equal to angular velocity times the radius. Now, if I look up top, I'm given the diameter. So I need to figure out what the radius is from this diameter. And we all should know that the radius is equal to diameter of a circle divided by 2. So I can take this 2.3 meters, I can divide it by 2 to get a radius for this propeller that's equal to 1.15 meters. And now I can come down to my linear velocity equation. That's going to be equal to omega, where I plug in 126 radians per second times this actual radius that we calculated by doing the diameter divided by 2. That's equal to 1.15 meters. I multiply this out, and I'm going to get a velocity that's equal to 145 meters per second. And something we'll notice here is that technically this is a meter times a radian. Because if I look at my units, I've got a meter right here, and I'm multiplying it by a radian per second. So that should be a meter times a radian divided by a second. It turns out that radians are kind of a special unit. They're kind of a placeholder. So they have no physical significance. These are placeholders for kind of describing a distance in terms of a radial value. Okay, so these are placeholder units. They don't represent anything physical. So when we multiply by a meter per second, we can kind of drop the radians. Then finally, we're asked to find the centripetal acceleration. And we know that the centripetal acceleration, AC, is equal to v squared divided by r. We know that it's directed towards the center of the circle of this propeller. So we can take our linear velocity from part B, and we can plug that in, 145 meters over seconds. And we want to square that. And we want to divide by a radius of 1.15 meters. And when we multiply all this out, we get a final answer of 1.82 times 10 to the fourth meters over seconds squared. So again, that's 1.82 times 10 to the fourth meters over seconds squared. And we're not quite done because we also want to know what this is by converting to multiples of g. So to convert this into a multiple of g, I take the centripetal acceleration, AC, and divide it by the value that we know for g, the acceleration due to gravity. So I do 1.82 times 10 to the fourth, and I divide that by 9.8. Each of these have units of meters over seconds squared. So when I divide this, the units are going to disappear, the units go away, and I get a final answer of 1,857 Gs. So if you've ever heard of pulling Gs in a plane or in a fighter jet or something, that's what they're talking about. It's how many times the acceleration due to gravity you're getting, and this particular propeller is spinning at about 1,800 times the acceleration due to gravity. So that's how you do kind of linear velocity, linear acceleration, and angular velocity and angular acceleration kind of problem.